exponential functions and logarithms. Exponential functions are similar to polynomial functions, except where the x is in the base. With an exponential function, the x is, or the unknown is in the exponent. Instead of x squared, where x times x equals x squared, we got something to the x. For example, y equals 2 to the x. And I've plugged in the function here, y equals 2 to the x, if x equals negative 2. 2 to the negative 2 is the same as 1 over 2 to the 2 squared, or 2 to the fourth. 2 to the negative 1 is the same as 1 over 2 to the first, or 1/2. And anything to the 0, 2 to the 0 is 0. 2 to the first is 2. 2 squared is 4. 2 to the third right here is 2 times 2 times 2 is 8. 2 to the fourth is 2 times 2 times 2 times 2, which is 16. And so on. I've gone from all the way 2 to the 6, which is 2 times 2 times 2, 6 times. And that leaves us to 64. And you can see the graph on the right here is an exponential function. It's usually very flat on one side as it approaches closer and closer to 0, and then gets very steep very quickly on the other side. Now, here you see the reverse here because we got y equals 1 to the third x. In other words, if I got something to 1/3 by putting a negative in the power, 1/3 of the negative 3 is the same as 3 to the third. That's 27. As our numbers get larger here on the x, because this is a fraction, it gets smaller and smaller for the resulting y. And we have the same thing here. It rises very quickly on one side, except this time it's on the left side. On the right side, it gets very flat. Now, I want us to graph on a problem here, y equals 2 to the x minus 1, from x equals 1 to x equals 4. If I put in 0 for the x here, 0, 2 to the 0 minus 1 is 2 to the 1/2, which 2 to the negative 1, which is 1 over 2. And I can see where I put in 0 here. Here is 1, because here's 2 right here. And here is 1/2. So at x equals 0, y equals 1/2. When I put 1 in there, 2 to the x minus 1, 1 minus 1 is 0. I'm sorry. 1 minus 1 is 0, and anything to the 0 power is 1. 2 squared, and anything, 2 squared, 2 times 2, and I got 2 to the x, 2 minus 1. 2 minus 1 is 1, and that is 2. And 2 here is right here. If I put in 3 for the x, 2 to the 3 minus 1 is 2, and I put in 3, it becomes, here's 3 right here, and the resulting y is 4, as shown on the graph here. I put in 4 for the x, 2 to the 4 minus 1 is 3, and 4 would be, if I put 4, and you can see we're approaching it, it's not on the graph here, is 8, be somewhere up here. Again, it's a standard exponential growth function. Now let's talk about logarithms. Logarithms are another way of showing exponential functions. The reason we have logarithms is because a lot of times things grow very quickly. For example, on the seismic scale, an earthquake could be seismic level 2, another earthquake seismic level 3. It's not 1 times as large. It's a 0. It's an exponential function. It's 10 times as large. There is, let's say, a seismic earthquake level 1, that is 1. Seismic earthquake level 2, that is 10. 1, 0, there's 2 digits. Seismic earthquake of 3 is 100, there's 3 components. Seismic earthquake of 4 is 1,000, there's 4 numbers. So, and it's hard to graph something when it's moving logarithmically when you have a scale that large, 10 to 100, 1,000, 10 to 100, 10,000, 100,000, million. So we develop logarithms. We have logarithmic functions instead. And all we're doing here is we're rearranging everything. And I've got here example log 5x equals y. This is the base. That little 5 right there I've underlined. That means 5 to the 0, 5 to the first, 5 to the second, okay? And then y is the power. 5 to the 0, and the 0 is 1. So this would, if we had this would be log 5 equals 1, it'd be 0. Let's look at this one here. Log, in the middle one here, log 5, and this is what the base is, and we have equals 2. Well, this is the same as 5 squared equals 25. And that's what, that 25 is what goes there. So this is log 5, 25 equals 2. We're basically saying this base to this power gives this resulting answer. So log 5, 625, right here, equals, bad equal sign, I apologize, but equals 4. And really what we're saying is 5 to the 4th equals 625. Let's look at some examples here. Log x to the 16 equals 2. We don't know what the x is, but if the result is 16 and the power is 2, what would work there? Well, 4 to the second power, 4 squared equals 16. So x equals 4. Log 5, 25 equals x. Remember, it's 5 to the something would equal 25. X would equal 2 here. Log 5 squared is 25. So 5 to the 20, log 5 25 equals 2. Log 3 to 27. So the base is 3. What 3 to what power equals 27? Well, it's actually third. 3 times 3 is 9 times 3 is 27. So x is 3. Now we can solve some problems here. What's very interesting is using the same algebraic functions. This looks a little scary here. 2 to the 3x minus 5 equals 16. How do I solve that? If I can get the same base and same exponent, I can solve it algebraically very simply. So I got 2 to the 3x minus 5. If I can get that 16 to a base 2, I can solve this. 2 to the 3x minus 5 is the same as 16 is the same as 2 to the 4th. Now I've got two bases. So I'm going to bring down here, I'm going to bring down 3x minus 5 on one side, 4 on the other, and I'm going to solve this algebraic equation. This is like from the first week. 3x minus 5 equals 4. I add 5 to both sides. So I'm left with 3x equals 9, which x equals 3. Log 2 to the x equals 3. What base 2, if we have base 2 to the third power, 2 times 2 times 2 equals 8. So x equals 8. Now I got some problems here to do. 4 to the 3x equals 64. Well, I need to get both sides down to a base 4. I got 4x cubed on one side. Well, 4 to the third is 64. 4 times 4 is 16 times 4 is 64. So I've basically now got two same bases. And I got 3x equals 3, which I bring down here, which means x equals 1. Here's another one. 3 to the 5x equals 27. Can I turn 27 into a base 3? Yeah, 3 to the 3 cubed, 3 to the third. 3 times 3 is 9, times 3 is 27. So 3x to the 5th equals 3 to the third. I've got same bases. I bring these down. Now it says 5x equals 3. And I solve it algebraically. X equals 3/5. Problem 3 here. Log x to the 4th equals 4. 4 to the what equals 4? Well, I should say 4 to the 4th is 256. And the last one here, log x, log 7 of the x equals 3. And I'm basically looking at base 7 is the base to the third power. 7 times 7 times 7. 7 times 7 times 7 is 343.